Hi, so we're going to talk about how the idea of duck typing can apply to polymorphism. So in a previous video, we see how to apply the idea of duck typing to defining a function or a method, and especially in the case where a parameter of the function or method does not have all the expected attributes that the function or the method needs, then an exception is raised to report the error. So duck typing as well as exception, they are together, they are very Pythonic way of writing Python code. So here we want to see how the same idea of duck typing can be applied to polymorphism. And I'm going to use the same example that with which I explain polymorphism when we talk about inheritance. So just as a quick recap, at the top of our inheritance hierarchy is person, and person defines a method called worries that returns a list of things that the person worries about. For a person, it includes money, and the teacher inherits from person, and the teacher, in addition to what a normal person worries about, he or she also worries about lectures. And also same thing for a student that also inherits from person class, and the student would additionally worry about quizzes and assignments. And now we have a print worries function that, given a list of people, it just goes through and prints out what that person worries about. Now I changed the name of the list from people to a list of entities, as not to discriminate against non-humanoid life forms, and I'll explain why I did that in an instance. So now I instantiate person, teacher, and student here. They're all in the list, and this list is passed to the print worries. And when I run it, then it prints out the list of worries for each of the person respectively. And I do a check of making sure things in the list is of the type person, and if it's not, like a string, then we cannot call the worries method because it probably does not have a worries method. Now, what if I now want to use the same print worries function to print out worries of all life forms, not just people? And for example, I have quite a few squirrels in my backyard, and I can see that they worry about their food, right? So their food includes acorns. So to represent squirrels, I can define a squirrel class. Now, squirrel obviously is not a person. It really has nothing, almost nothing in common with a person. So it makes no sense that a squirrel would inherit from a person, right? So, however, squirrels, like I just said, they have their worries, right? So for squirrel, the squirrel class, I can define a worries method that returns a list of things that squirrels worry about, acorns. And now if I instantiate a squirrel and add that to the list of entities that I pass to print worries, do you think that we're going to print out the worries of our squirrel? Well, let's run it. And no, it totally ignored the squirrel. And I hope that you can see why. And that is because we have a check for the type of the things or entities that are in the list. If the thing is not a person, then we don't think they have anything to worry about, and we just ignore them. So that is a potential problem of checking for types. Now, what if instead of checking for types, we apply the idea of duck typing, so that what we'll do is we will just try to call the worries method of any and all entities in this list of entities. And if it succeeds, then we print out the worries of that entity, whether it's a person or a squirrel or anything else. But if the worries method does not exist, then we'll get an attribute error. In that case, we'll just not do anything for that entity. So if we do this and let's run it, then indeed now we would just print out what the squirrels worry about. And I hope you can see that if we define in the future more types that have this worries method, then this print worries function will work for them regardless. That would be very unlike this previous version of the print worries function, that it will only work if that entity is of a type that inherits from person. Now, this way of applying the idea of duck typing is one of the three ways that we talked about previously, right? So this idea is we just try it, and if we run into an error, we handle the error. Now, can we not handle this error at all? Well, it won't work in this case because let's say we have a string here, and it certainly would not have the worries method when we try to run this line. So if this is not in a try and except block, then this would crash this print worries function. So that's not a good idea. So that's off the table. Now, what about the other approach, which is to check if the entity has the worries method, and if it does have it, then it would call it. If it doesn't, then it will just skip it, right? So this idea would also work, but in my opinion, it's a little less desirable, just because I see the word worries in two places. So if I actually, for whatever reason, say I rename the name of the method, then I have two places to change in this function instead of just one. So I would still prefer, at least in this case, this version of the print worries function. And finally, just a small exercise for you, that we know many of the Python built-in types, such as length and tuple or strings, they support the length operator or built-in function. But there are other types, such as float and integers, that do not support the length operation. So if we are given a tuple that has many different types of items, can you write a for loop that would print out the length of the item if there is a length for the item, or an error message if that item does not support the length operation? So please pause the video and give this a try. And assuming you have time to do that, and this would be my approach. And that is basically the same for loop. I'm going to use the try except method in this case, and I'm just going to call thing for the thing in things. I'll call the thing dot length operation, and if it's good, then we get the length of it. Otherwise, we'll print out the message that the thing doesn't have a length. So when we print it, we see that the first three things, they all have lengths, but the numbers, they do not have length.